Hello, everyone. I'm going to talk about my research on ethical recommendations. I am Murali Mani. I'm a professor of computer science at University of Michigan Flint. So let's think about where do people go for news or information. Right? Traditionally, people used to go to newspapers or listen to TV and radio and so on. Increasingly, people go to YouTube, Facebook, Twitter, and so on. Right? At the same time, what we see is in the last several months, there has been a tremendous increase in misinformation, and it has had real consequences. Families are being torn apart, parents are not able to communicate with children, and so on. The question is, why is this happening? Let's digress a little bit and look at a topic called recommendations. About 20 years ago, the computer science community introduced the idea of personalized recommendations. To summarize it, what it does is, if we search for football, it gives us Michigan football. It will not give us Spartan football, and it absolutely will not give us Ohio State football. Okay? It's used extensively by many companies. Of course, the question we are looking at is how good are these recommendations, especially related to news and information. So who should be investigating this topic and who are? The social media companies are investigating this. They are looking at flagging misinformation, removing content, and so on. But the question is, are they investigating their algorithms, the optimization goals of their algorithms? I believe that the academic community has an obligation to study this topic. So at U of M Flint, we have been looking at this topic specific from January of this year, January of 2021. It has involved me, a couple of undergraduate students, and a colleague from Penn State University. So we have narrowed the scope considerably as our first problem. We are looking specifically at social media posts on Reddit, and we are investigating how communities are being promoted within other communities and how they are being promoted by certain members. So this is a simple chart. This shows you, for instance, it shows that the ballet community promotes, within the ballet community, you see a promotion of the ballet community, which is itself, and also conspiracy. At the same time, if you look at flat earth community, it promotes many things. It promotes anti-vaccine, it promotes flat earth and flat earther, it promotes birds aren't real, it promotes conspiracy and conspiracy theories and so on. Okay, so there is a huge range of behaviors exhibited by these communities. If you look at authors, so we see a similar thing, which is there are some authors who are prolific across multiple communities. So for instance, this author publishes in conspiracy theories, anti-vaccine, flat earth, and Trump virus. And there are some authors who are mainly contributing to one community. So this is what we have been studying so far. Right? Of course, this is just the tip of the iceberg. And we are still working on formulating the bigger questions in this context. And if you're interested, if you have any comments about any of these things, or if you have questions, or if you want to be part of this research, please contact me at mmani@umich.edu. Thank you very much.
Hi, I'm Robin Fowler. I'm a lecturer in the College of Engineering and Technical Communication, and I'm also an assistant research scientist in engineering education research. And I'm here to pitch a project with a tool called Tandem. Okay, so Tandem is a web-based team support tool that we are developing with the Center for Academic Innovation, and it collects information from students at the beginning and end of the term on their identification with the discipline, on their work styles, on their motivation, on their goal orientation. It has algorithms built in, and it can form teams now. It has tailored teamwork lessons, so it uses the Michigan tailoring system to change out paragraphs. So for example, if one student is doing much more work than others, or one student is doing less work than others, they can see different paragraphs within a lesson. It has peer and self-assessment on teamwork related phenomena, as well as tailored feedback, so students can see here's how you rated yourself, here's how others rated you. And then it has weekly team health checks. And as you can see, we're sitting on a lot of data. This tool is designed to help students' experiences with teamwork as it happens in classes, as well as to improve their teamwork abilities so that they can learn more about themselves and develop new strategies that they can take into teamwork experiences beyond U of M. And it's designed to do all of this through an equity lens. So it thinks about, or not thinks about, but it is sensitive to the ways that teamwork can be inequitable. And it is intended to highlight some of those patterns to both the faculty supporting the teams as well as to the students on the teams, and to give them strategies to push back. As you can see, we're sitting on a lot of data, and we would be really excited to partner with someone who can handle this in more sophisticated ways than we have been so far. So I can do my ANOVAs and t-tests, but I would love to work with someone who can help us take this a little bit further. Ideally, someone who would be motivated to think about improving student teamwork through diversity, equity, inclusion, and justice lenses, through DHEA or DEI or whatever acronym you prefer, but just thinking about what does equity look like in student teamwork and how do we push our world to be a little bit more the one that we want to be in. And ideally someone who is wanting to use mixed methods to do so. So we have what I consider a really big data set. I'm sure most of the people in this room will not, but we have about 4,000 people, I think, using Tandem this semester, and the idea is that ideally it would continue to grow. And so the data set is fairly large, and we'd be excited to work with you on research questions that you come up with, as well as things that we're interested in. I'm personally really excited at the idea of using machine learning to tweak our team formation algorithms or to create new team formation algorithms and to better predict team outcomes. So we have a lot of information about students as they approach the team experience in the first place. Can we start to predict what sorts of student groupings might result in what kinds of results? And then also, can we use natural language processing? So we have student reflections throughout those tailored lessons. We'd like to better understand the nature of student responses, what does an engaged response look like, as well as to be able to extract information from those student responses. Yeah, so I would be really excited to work with someone or to answer any questions right now.
Hello, I am Ayumi Fujisaki-Manome at Cooperative Institute for Great Lakes Research. Today, I'll be introducing our new project funded by MIDAS Part 2021 grant opportunity, which is titled as Supporting Decision-Making for a Vital Waterway in the Great Lakes by Machine Learning Model-Based Lake Ice Forecasting. The Great Lakes, shown on the right, support the maritime transportation system in the United States and Canada. It is vital to the economies of the region. In winter, lake ice becomes a concern for navigational safety, especially for connecting channels such as river systems. St. Mary's River, which connects Lake Superior and Lake Huron, is one of such waterways. On the left, the picture shows commercial vessels waiting for an escort by Coast Guard in St. Mary's River. Lake ice condition is very dynamic, so that it is very important to have the capability to forecast ice condition ahead of time. Process-based numerical models are capable of providing forecasted conditions of lake ice. The right figure shows an example of simulated ice cover in Lake Erie from such a process-based model. However, these models have limitations. First, process-based models are often computationally expensive. Second, they have challenges in resolving physics when it is applied to relatively small geographical areas such as river systems. Machine learning models can be an alternative to process-based models since they are cost-effective and can be trained to represent key variables that are most critical for decision-making. In this project, we designed a prototype ice forecast system for St. Mary's River by implementing two machine learning models based on XGBoost and LSTM. The input data include atmospheric data, climate indices, water surface temperature, and ice data. Our preliminary results showed promising performance in predicting time series of ice coverage over the river system. The team is currently conducting model optimization and skill assessment. Following them, we plan to provide a prototype forecast for the upcoming winter season. While doing so, we are interacting with the forecast officers at National Weather Service to evaluate the prototype. We also plan to present the findings at the scientific conference this coming November, and a manuscript will be prepared early next year. I would like to thank all the collaborators listed here for providing their expertise, and thank you for watching. If you have any questions, please feel free to contact me or any of our team members.
Hi everyone, my name is Paramveer Dhillon and I'm an assistant professor in the School of Information, and I'm excited to talk to you about one of my recent research projects. So as we all know, recommendation systems are highly pervasive and they're all around us, and they can be found at places like Amazon to Netflix to Facebook and Google. So all of us know that if you watched a Star Wars movie, it might recommend us to watch a movie like, say, Star Trek or Tron. And at the heart of any recommender systems, they optimize based on your past consumption history. That is, the recommendations that they give you, they are harvested from your past consumption history. Now, this myopic behavior of recommender systems, where they just optimize on your past consumption history, could lead to the formation of filter bubbles or echo chambers, where increasingly over time, as several studies have shown, a user's consumption is highly homogenized. That is, people start consuming the same kind of content over and over again. And as you can guess, this is highly detrimental to our society because it could lead to societal fragmentation and increased polarization. So the research question that I am interested in is, how can we design recommender systems that improve societal welfare? Some of the objectives that one could think of optimizing, other than just myopically optimizing for past clicks, are to optimize for diversity of consumption, or to optimize for serendipity, or to optimize for unexpectedness. So now, a natural question arises, what are the pros and cons of incorporating these objectives into the optimization of machine learning based recommender systems? Are any of these objectives socially optimal? If not, can we think of other objectives that might lead to better societal outcomes? If you are interested in any of these questions, please feel free to send me an email at this address. And I apologize that I could not be there in person for this research pitch. Thank you.
Hi, I'm Dr. O'Brien, Elle O'Brien from the School of Information. Here's my pitch. So lots of labs are interested in getting involved in machine learning and data science as tools or methods for basic science research or translational medicine. There's so much enthusiasm, and it's really cool, except I have a few concerns because even the most well-funded organizations have difficulty making data science really work. So from the Netflix data science team, here's a quote: "From experience, we know that much of the pain related to operating modern machine learning infrastructure is caused by the complexity of large-scale distributed systems." So complexity, we've got lots of people involved, working on the system. We've also got huge data sets with specialized storage needs, specialized computing hardware needs, and an enormous parameter space to explore. So tech companies have a bit of a leg up on dealing with complexity because they're used to it. So in your typical tech company, there's a constant tug of war between teams that make cool new features and the folks whose job it is to keep everything running without interruption. And practices like version control and frequent code testing have sprung up as an answer. And collectively, these approaches and conventions around managing the complexity of having an evolving product is called the DevOps movement. Now, when we look at labs, which in my experience are like software companies in that they write a ton of software and they do publish, they productionize something, which is a paper, these practices are often missing. So my experience comes from biomedical neuroscience research, so maybe it's different elsewhere, but in my experience, we don't have a culture of using version control. So for example, everybody emails their code to one another instead of doing Git versioning, or there's not a lot of code portability. That code will work on my laptop, but not necessarily my lab mates. And then all this gets much harder when we've got data sets that won't fit on anybody else's laptop. So this can be okay for some labs. It's not like a universal problem, but I do think it's going to be really hard for your average research group to start using data science without some of these practices or conventions in place. So my question is, how do we help labs develop the infrastructure it takes to use state-of-the-art machine learning and big data approaches? I'm in the planning stages for some qualitative research about the factors that enable some research groups to start using data science as part of their workflows. So I think we have to do some case studies about successful labs using data science as part of their meaningful workflows that will help us generate hypotheses and learn how to ask the right questions, which we can then begin to address at scale. And the ultimate goal of my work is to help scientific researchers have stronger computational infrastructure so we can improve the reproducibility of science generally, but also help them take advantage of the most powerful tools available to them if they so choose. Now, if you're interested in helping me plan for my grant proposal, then I would love to talk to you. Thanks very much.
Hi everyone, I'm Xu Wang, an assistant professor from the Computer Science and Engineering Department. My research interests include human-computer interaction, learning sciences, AI-augmented learning experience design, human-AI collaboration, and medical education. I'm very excited to join MIDAS and get to know everyone here. Please drop me an email if you're interested in chatting or collaborating in any way. With the development of technologies, the definitions of professions and people's job responsibilities are rapidly changing. In order to fulfill their current job needs or get more professional opportunities, there's a growing need to learn new skills. One challenge to meet the demand is to scale these educational opportunities while maintaining or improving their quality. In my work, I tackle this challenge through developing computational methods and tools to support quality learning at scale. Specifically, there are three major themes. In order to support quality learning at scale, I believe it's critical for instructors or experts to create engaging and effective learning experiences for novices. Thus, I develop systems that empower instructors and educators in learning experience design, which in turn benefits the students who are receiving these educational services. In the process, I'm in particular interested in human AI approaches to achieve this goal. Lastly, with new technologies, they offer new affordances to students. This also allows us to answer new learning sciences questions that were not possible to be answered before. In this video, I will introduce a system upgrade that semi-automatically creates high-quality multiple-choice questions by leveraging existing students' written solutions. Here's a quick demo. Assuming I am an instructor user, this is an interface that allows me to quickly create large numbers of multiple-choice questions based on past students' responses, as shown on the left. I'm currently specifying the question schema here. For example, I want my students to learn the alignment between user need and storyboard, and now I'm entering the question stem. And next, I specify the correct answer. And next, I want three similar distractors here. The distractors are selected based on the text similarity with the correct answer using natural language understanding techniques. The right panel is showing a preview of a question under this schema. In Upgrade, past peers offer a powerful data source with structured examples that show common errors. With this better data input, machine can auto-select, filter, and reorganize examples. In this process, instructor is also communicating their needs, such as I want similar examples or technical answers to guide the machine in selecting examples. In the end, instructors will check information accuracy and comprehensiveness. This altogether supports the creation of quality learning opportunities for learners. Here are some future directions that I'm excited to pursue. Thank you everyone for listening, and please keep in touch.
Hello, my name is Yulia Sevryugina. I'm a chemistry librarian at the University of Michigan and MIDAS faculty. My research focuses on investigating trends in scholarly publishing, and I'm looking for collaborators and co-PIs for future proposals. The scholarly publishing landscape reflects how science evolves. You can imagine some fields come to flourish and entirely disappear, while new ones emerge and become popular. For the last century, we have seen a tremendous growth of scholarly output. In 2018, the number of English peer-reviewed journals reached 33,000, and they were publishing over 3 million papers a year. We live in a world full of information that we are learning to navigate. My group is measuring and analyzing this information. We are using various APIs and databases, and with Python coding, extract and visualize this data so that we can absorb the global trends in science communication, answer questions on how authors' behavior, perceptions, and attitudes affect scholarly output, how social media and scholarly collaboration networks impact the scholarly infrastructure, and how historical events influence the science development. For example, this image demonstrates how different disciplines or topics react to a specific historical event. By analyzing the research output over time, we can observe different behaviors for different disciplines that together refine the scholarly landscape. Measuring and analyzing bibliometric data has become an integral part of research evaluation and plays a crucial role in making decisions about national research policies, funding, promotions, job offers, and directly influences the careers of scientists. To advance our study of the complex phenomenon of knowledge creation and dissemination, I'm looking for collaborators to build mathematical models that could statistically describe this dynamic system, help further understanding the observed trends, and perhaps predicting some. If you are interested in collaboration, I would be happy to provide more details. Thank you.
Hello, everyone. I'm Nathan Martin. I'm Associate Professor of Music in the School of Music, Theatre, and Dance here at the University of Michigan. I'm a music theorist, and I'm especially interested in computational and other empirical approaches to music theory, both for the ways in which these kinds of tools might allow music theorists to approach the kinds of problems we've traditionally been interested in, and also for the new kinds of questions that the tools suggest that we could ask. For now, I'm mostly interested in making contact with other researchers and students across the university who are interested in these kinds of things. And my hope is eventually to establish a bit of a network and community around computational approaches to music theory here at the University of Michigan. Some of my current projects undertaken with graduate students in the School of Music, Theatre, and Dance include a study of cadence types, correlations between cadence types and formal position in a fairly large corpus of works by Mozart. A study of the modal organization of the Bach chorales using unsupervised clustering on pitch class histograms. And a study still more or less in the planning stages of harmonic successions in Guillaume de Machaut's music using n-grams. So if these or other related kinds of studies are of interest to you, please don't hesitate to get in touch. I would be delighted to talk further.
Hi, everyone. My name is Robert Manduca, and I'm an assistant professor of sociology here at the University of Michigan. And in general, my research focuses on economic inequality and urban economic development. There's two broad research projects that I'm interested in talking about with people at MIDAS and potentially working with you all on. The first one is a project that looks at modeling urban economies and specifically asking, where does economic activity happen and who has access to it? This is something that has become an increasingly possible topic to study in recent years as the data availability or data access gets better and better. So in some previous work, I've looked at economic complexity at the metropolitan scale, sort of asking which industries are in which broad metro areas. And I've also done some work on identifying specific business districts within cities. So using block level data, like the data that's shown here, where I'm plotting jobs in metropolitan Detroit, the location of jobs in metropolitan Detroit, to identify business districts. So going forward, what I'm interested in doing, and definitely would be interested in talking with people about, is linking this all together. So asking more, taking advantage of some of the data, some of the additional variables that are in the data sets that I'm using to study things like, exactly which groups of people or individuals are able to access which kinds of jobs, how commuting patterns are reflected in or impact who gets what jobs, and also sort of how far people have to travel in their day-to-day lives. And then potentially even getting other types of data to study sort of where spending is happening. And when people in a given city get a raise, does that go to businesses that are locally owned, or does it mostly go out of the local economy? The second major project that I'm working on right now is a project to study consumption patterns. So this is something that sociologists have been interested in for a long time, but they usually study it using qualitative methods. And so I have data. I've been working for the past year, actually, with some people that I met at the research pitch last year, some students in statistics here, to analyze the Nielsen consumer panel data, which is a large data set. It's at the UPC level, so individual barcodes, and it has a representative sample of about 40,000 people for more than a decade. And so we've been looking at patterns in this data in terms of who buys what kinds of products and what sort of commonalities emerge. And one thing that I would love to get people's help on is it's become apparent that the types of clustering and dimensionality reduction algorithms that me and my collaborators are familiar with are probably not going to be necessarily up to the task here. And so we'd love to talk to people who have expertise in these areas, sort of how do you identify clusters of products or groups of people who buy the same sorts of things. And in particular, in cases where we have far more products than we do people in our sample. So high dimensional data expertise would be great. So yeah, I'm looking forward to talking to you.
Hi, thanks to MIDAS for having this great session, and hopefully we're getting to see a lot of interesting talks today. My name is Anthony Vanky, and I'm an assistant professor at the Tubman College of Architecture and Urban Planning. And I'm working on a project that's looking to use computational social science approaches in looking at a question of neighborhood change and gentrification. Specifically, I'm hoping to look at the use of data from these online platforms such as Yelp, Google Reviews, to actually help us get a picture of how neighborhoods change. And when we talk about gentrification, a lot of times we talk about it through what businesses are there. There's the whole kind of story about the hipster coffee shop coming in as an omen that this neighborhood is gentrifying or gentrified. But more specifically than just gentrification, it's also a question of neighborhood change. Demographic change. Are different types of people coming in that were there? And more importantly, are people now being displaced as a result? So when we look at the question of gentrification, one way we can look at it is the relationship between income and housing prices. And we're using this as a base to really question how neighborhoods are changing as kind of the left-hand variables, the outcome variables. And we're working with a couple of researchers that have access to data to Morningstar, credit reporting data, as well as housing information, where we can actually begin to quantify over time whether these neighborhoods have changed or not. But when we think about what's available to us through these online platforms such as Yelp, it's not just whether there's a coffee shop, but we can see businesses opening and closing over time. We can see how ratings fluctuate and who's actually rating. We can see characteristics such as menus, or whether there's a propensity for a place to have amenity businesses such as hardware stores or car repair shops versus maybe more going out or special event times like restaurants or bars. And what do they look like? Are they gyms or are they yoga studios? Are they commodity coffee like Dunkin', or is it fancy places like Comet? And if we look at these patterns, we can actually get a really interesting picture of how a neighborhood changes. But I think more specific than just looking at whether it's a fancy French restaurant or a burger joint, we can actually look at the characteristics of how people view these places, because we also have valuable information being contributed by people. So if we look at the example of one of my favorite fried chicken places when I was living in New York, Lincoln Fried Chicken, no one will ever call this a fancy place. But when you look at the reviews, you see something pretty interesting. For instance, the use of the word hood. That if we look at the slang use of this, it could mean something kind of negative, talking about maybe it isn't as fancy or it doesn't kind of rise to a level of service or amenity that people are looking for. But in another way, if you use it as a term hood chicken, that could be a superlative. So through this research, we're not just hoping to see whether, having certain types of businesses or their characteristics tells a story about a neighborhood. We're also looking at ways to valorize the lived experience of people through their spoken language, through the vernacular language, and through valorizing slang, making kind of important that informal language, which normative NLP, natural language processing approaches don't really value or don't really capture in a valuable way. So how do we be deductive in our process through how people talk? But then also looking at how these patterns also change over time may tell us a different picture about this neighborhood. So really this project is hoping to be at the intersection of many disciplines: computation, big data, of course, data science, but also anthropology, urban economics, sociology, urban studies, and planning. So I hope to talk to you later, and hopefully you also give this pitch a thumbs up and 5 stars.